Gates. But let me now introduce Gloria Jimenez, who's a Ph.D. candidate here in the Department of Geoscience at the University of Arizona. Maybe you could just wave so people know who you are. And Gloria is a paleoclimatologist interested in linking climate change research with real-world problems. She's a Ph.D. candidate in Geosciences at the University of Arizona, and she uses corals from the Galapagos Islands to reconstruct the recent history of the Eastern Pacific Ocean, with the goal of understanding how this area and El Niño will respond to climate change. Gloria sees science as an incredibly powerful tool with which to change the world and hopes never to work in an ivory tower. She is a returned Peace Corps volunteer who served in Ecuador and holds a PA from Carleton College, an MS from the University of New Mexico. And when she takes off her scientist hat, Gloria enjoys collecting athletic hobbies and recipes. And finally, Joanie Kleypas, yes. She is in the Climate and Global Dynamics Laboratory of the National Center for Atmospheric Research, also known as NCAR. She's a marine scientist in that institute who studies how climate change and the ocean's acidification affects corals. She did her doctoral research on the Great Barrier Reef, but now studies reefs from a mile high in Boulder, Colorado, using supercomputers to identify where coral reefs can survive in the future. She recently established a coral reef restoration pilot project in Costa Rica to speed up the recovery of reefs by growing corals in underwater nurseries and then transplanting them back into the damaged areas. She's an Aldo Leopold Leadership Fellow, the same as Julia Cole, and has given numerous educational public talks on coral reefs and climate change. She's testified multiple times to the US Congress, and in 2011, she was a recipient of the Heinz Award for the Environment. She is still just a kid in the water, excited to learn about the ocean and her beautiful creatures. Thank you all for being here today. So I'd like to just ask a few questions to the folks here, and then I'll ask all of you to ask questions, unless you don't have any, and then I'll keep on asking questions. So how about if we try that, okay? So this is a question, I think, specifically for Julia, who's a paleoclimate person. And one of the things that I think some of the deniers of global climate change always use is deep time, and how the Earth actually has survived being an ice ball, and how it survived temperatures that were warmer than we have today when the dinosaurs were around. What can you tell us about the differences between the times of the past and now that may have very different consequences to the changes that we're seeing?
Sure, that is a common question that we hear a lot, especially from those in the geosciences. The Earth has been warmer than today. It has been colder than today. It's gone through natural climate cycles as far back as we know. The difference today is two things. One, the rate of change is extremely rapid. It's much more rapid than the large changes that we're familiar with, for example, coming out of the last ice age. Secondly, we as a species depend on so many aspects of planet Earth today. If climate warms rapidly, the Earth is not going to disappear, right? The Earth will not die. But the things that we depend on in the Earth will be gravely threatened. And as was pointed out in the movie, between 500 million and 1 billion people depend on coral reefs for food. Coral reefs provide coastal protection. And so when we're looking at an ecological crisis of the magnitude that we're talking about here, we're looking at a system that is very, very vulnerable to these very rapid changes that we are imposing on it, and people will suffer.
Would anybody like to add anything to that?
No, that's good.
Okay. Okay, well, the second question that clearly has to come to everybody's mind is that it's going to be, regardless of how fast we stop emitting fossil fuels, to dramatically slow the heating of this planet. Certainly, I think every model that anybody can see and believe argues that in 20 years, that median curve that was shown there is probably the most realistic. If we're lucky, it'll be a little lower, but And that's not to say that we shouldn't stop emitting greenhouse gases, but it's realistic to believe that it's going to be hard to slow the consequence of all the gases that we have already in the atmosphere. So Joanie, maybe because you're actually working hard at this, and so is Ruth, what can we do under those circumstances to either protect corals or make sure they don't disappear as an ecosystem?
Well, I'll start first, but I know Ruth has a lot to say on this too. So, the standard thing has been over time is we know this climate change was going to be affecting corals for a long time, just like the person Ove Goldberg said in the movie. It's like we saw this coming, but the idea then was if we just protected reefs, if we prevented all those other stressors, pollution, putting organic, all kind of over nutrients in the water, overfishing, all these other problems we do for reefs, that they, the strongest ones would make it through. We realize that that's not going to be enough now. So some of the work that you can do is you can try to find those little pockets, those places where corals have the best chance of surviving. You can do that, or you can go in and start manually intervening with, doing things like growing stronger corals, so building, better corals for the future, or trying basically some very exciting things, and I'll let Ruth take it over from here. But we only have 25 years to do this, and so we have to move really rapidly to get this going if we're going to save them. But part of the movie that I think sort of misses out on is like what those things are and what can give you hope and what we should be shooting for. And so Ruth is the master of hope on these things, so I'm going to pass it to her.
Master of hope. Well, I mean, I think that, Joanie hits it on the head. We've usually moved down conservation through protecting ecosystems and having a much more hands-off approach, and it's not going to be sufficient, and we know that. And so myself and many other people now around the world are exploring interventions that involve the assisting of the evolution of the system. So, we've talked about the rates of change being extremely rapid, and so the real problem is the rates of adaptation in the corals themselves are not keeping up with the rates of change in the environment. And so we know a lot about the corals that survive, and we've done 25 years of basic research that tells us who your parents were. If you were just lucky and you had parents that are really strong with respect to environment, that you're likely to survive. We know that there is nuances in the partnerships with microorganisms that can essentially give one coral the ability to survive conditions that might kill another. And we also know that if a coral has survived a past experience of stress, they're more likely to survive a future one. And so we're asking whether we can actually harness that knowledge and manipulate it through selective breeding to control and genetically direct the parentage, to breed the strongest corals that can be outplanted to the reef, or manipulate the microbiome to create partnerships that are strong and better able to withstand particularly temperature disturbance, and challenge corals by really essentially running them on environmental treadmills to give them an experience that is a sort of a glimpse of what's coming down the pipe, but that they survive with the hope that we can induce rapid adaptation through epigenetics in the system. And so, we're doing proof of concept work, but the idea would be to scale that to many places to have an impact. And, I've said quite recently that I think the challenge isn't really going to be the science. It's going to be interacting the science with the practice of restoration rapidly to direct it. So it's a disaster for the reef, but it's driving scientists and the science, I think, to be more creative and more focused on a solution than we would normally be. And so it's pretty exciting times.
Before I go to Gloria, I think it would be important, don't give her the microphone yet, because I think what you say is profound, and I think it's important to be explicit to this group, perhaps, of the ethical arguments that go on in restoration that are at the heart of what you're trying to do and Joanie is trying to do, which in some cases mimic the restoration issues that happen above water, but that maybe you can just explain a little bit of that.
So, I mean, we're moving into a different time with conservation, and so we're up against this sort of traditional view of it being enough if we just protect. But when we look at the evidence is pretty clear that it's not going to be sufficient. And so what we have is this sort of problem of moving the needle emotionally, I think, as a community of scientists even, to accept that we have to intervene and that we may have to intervene with approaches that we feel reluctant to use in wild systems. And yet when we really step back from the edge of what we do and what we're proposing we do and compare it to what we do in our lives, in our health treatments, we are conducting pharmacological experiments daily. Each of us, everyone in this room, doesn't know what really their treatments are doing to their bodies. We build houses and we clear-cut acres of natural landscape to facilitate our livelihoods. But when it comes to the natural marine system, we seem to have a reluctance that is putting up boundaries. And so I think a lot of the work that we have right now is about sort of reconciling these double standards and really asking what we're really concerned about. And some of the concern lies with, it's a very large problem. Can we possibly make an impact? And secondly, there appears to be a desire to compete the reduction in greenhouse gases, the mitigation of fossil fuels, with interventions on the reef. And that's not what we're doing at all. What we're really saying is we need to do everything we can possibly do to protect and sustain the reefs that we have now, if we have a hope of having reefs in the future. And to do that, we will need to really propagate the really tough corals that exist on the reef right now.
I just want to add one thing as a good example of where you get resistance. Suppose we lose all of the, in the Caribbean, we've almost lost the main species we have there called Acropora palmata. And, how do we get that back? You can spend a lot of time trying to grow it back, or you can go some other ocean and find one that's a lot tougher that can do the same thing that coral would do. It would be like replacing an oak forest that has died with some other species that could fulfill that same role and support the same bird species and all the things that we value. So one of the things people talk about is something called assisted migration, which is another part of this whole formula, is going like to the Red Sea, where the corals are naturally used to really warm water. They still bleach, but they bleach at a much higher temperature. You can take some of those and you can move them to another place. That gets a lot of resistance from people, because they're very afraid of invasive species. They're afraid of how that species is going to interact with the other corals on the reef. But those are the kind of chances we have to consider. But what the science can do now and start doing now is testing those interactions and testing whether those species will be invasive. So there's a lot of great opportunities out there to test some of these things. And it's really nice to get the public aware that those are the kind of things that we have to do, but that there are scientists also looking at all these risks and how to do that in a very responsible way.
So Gloria, here you have three quasi-eggheads coming from ivory towers. So the thing that you want to avoid the most. But what is the role, in fact, of entities like the Peace Corps and other non-for-profits in the restoration of reefs? And how do you go about also this particular ethical dilemma, which may not exist? So the question I'm asking you is whether it exists on the ground in the people that are actually have their livelihood from corals, or whether those individuals would appreciate any kind of coral that brings fish to them.
I mean, I don't think that I'm qualified to speak for the vast diversity of people who use coral reefs and products that come from coral reefs for livelihood or tourism or what have you. I think maybe as a blanket statement, people who depend on these reefs for economic reasons, for food, would probably prefer to have something rather than nothing. The question we've been talking about of what does it mean to conserve, what does it mean to preserve, what does it mean when we have an slow-moving ecological disaster that we have to deal with, and what are the hard choices we have to make to preserve these areas or not. I think the traditional view of conservation, particularly in the United States, has been, almost like place it in a glass dome and don't touch it. Don't throw trash, but then also leave no trace. And as we move into the 21st century, and this is my personal opinion, that is much more difficult to sustain as a philosophy. And nowhere is that more obvious than coral reefs, which are already feeling and will inevitably continue to feel impacts from human beings. So the sort of interventions that Ruth and Joanie were mentioning, like selective breeding, bringing in species from other areas, those are hard choices to make, and they go against the grain of a lot of people who assume that we shouldn't, bring in an invasive species. Well, if there's a choice between the invasive species or nothing, algae, then how do you make that choice, and who makes that choice? My experience in Ecuador, at least, was that people depend on these areas, they depend on these species, and they desperately want those environments to continue to thrive. So I don't know that I can really answer your question. It's a very, very hard knot to untangle. But I do think that looking at the disaster that we're seeing, the approaches that Joanie and Ruth have talked about give me a lot of hope that we can do something instead of just kind of cross our fingers and hope for the best.
Thank you. I think you did answer it.
Okay.
I'd like to open, unless nobody's brave, I'll continue asking questions, but we do have time for any of you to ask questions of this distinguished panel.
You spoke of assisted migration, but how extensive is the movement of these organisms by themselves to more northern or southerly waters?
That's a good question. That's also something that we work on. It's not just, where the corals are going to survive. We use climate models to look at that. It's also where the larvae are going to go, and are those pathways going to change in the future? And so one of the things we look at, and one of your own graduates who was a postdoc with me, Diane Thompson, worked a lot with this, is looking at those changes and seeing, identifying those reefs which are the best sources for larvae for other reefs that migrate around, and also the better sinks. And I was just talking with Ruth about that, about incorporating genetics into those things, because it happens to be that, if you're a reef that gets larvae from reefs that are much cooler than you, then as some of the stuff that Ruth was talking about, these larvae inherit from their parents and temperature tolerances. And so looking at those to help us guide where we should be doing these restoration efforts is really important. But just an article this week, I think it was in Science, is about a really cool coral called Passalopora damicornis. During the tsunami, made it on debris all the way from Japan all the way into the west coast of the US. So they can travel not just by larvae, they can travel as hitchhikers on all kind of material. Certain corals can. So they're kind of cosmopolitan in some regard, or have that capacity.
Hi, Haury. Thanks for coming. First of all, my name is Alan, and I'm here on behalf of the Intercultural Center for Desert and Ocean Studies. And we're doing a little bit of work with ocean acidification in the Northern Gulf. So I actually have a few questions. I'll ask them. I'll get them all out of the way. One is for Dr. Kleypas. I had the opportunity to work for a year as a coral restoration diver in the Dominican Republic. And although there was a lot of learning that occurred and a lot of hopeful things, I think the general picture wasn't very hopeful for me, because even though we were able to sort of build these successful colonies that wouldn't last very long, that last maybe a couple of years max. And on top of that, it was just very difficult work. And I sort of, with these hurricanes that just came through, I could picture it all turning sour very quickly. Also, other considerations I had were, using these plastic ties to attach the acropora to the reef. The amount of plastic we put into the ocean was impressive. So I was wondering if you feel that is a viable strategy on a wide scale. The other question I had is ocean acidification was something that wasn't really mentioned in the movie, and to me that is a lot scarier than temperature, because like Ruth said, you can adapt to temperature. I'm no expert, but it feels like it would be harder to adapt to a lack of availability of these biologically important compounds in the water. So I was wondering if you feel that is a more or less serious or on the same par issue. And then my final question is for Dr. Gates. This one comes from my colleague who was diving with me in the Dominican Republic, and he said you wouldn't like the question, but it was if you had a Skype call with yourself back in time, and when you were just finishing your undergraduate, and let's say hypothetically speaking that your only goal was to save coral reefs back then, I'm not sure if it was or not, what advice would you give yourself as far as which field of study would you pursue, and would you perhaps consider a more social science path than one that sort of just further stacks on evidence that humans are indeed affecting coral reefs?
Those are three great questions, and I'm glad I got the easier two. So I'll answer the acidification one first, because that's that one is, as you know, I've worked on that a lot. I'm pretty passionate about it, and I still think acidification is a problem. But right now, temperature is killing the corals, and if we don't do something about the temperature by the 2050, then acidification is going to be a problem for other organisms. So whatever organism you're interested in, I like to say that temperature kills the corals, acidification affects their ability to recover. So we need to control both of them, and that's why we have to do something about carbon emissions, is because if we don't, acidification will surpass temperature as a problem in terms of reefs, in terms of corals and their ability to build reefs and support biodiversity. So that is a great question, and but I think right now the urgency is the temperature issue. So the restoration issue, yes, these are small-scale things. I'm sorry you had issues with the Dominican Republic work that you were doing. Everyone has issues like that. It's a learning curve, and there's no, I think, disillusion or any illusion that we're going to save all the reefs through restoration efforts. But they are great underwater laboratories, and if we can do it strategically and put them in the right places in the ocean where they become seeds, and I mentioned larval dispersal. They are really good locations for seeding other reefs. And if we do it combining, just on their own, they're not going to work. But we need to start doing things like what Ruth is doing and incorporating these genetic adaptations or these adapted corals into those restoration efforts. Then we really can go a long way with that. The other thing we haven't talked about is using reproduction as restoration. So instead of you probably were using clips of the acroporas and growing them
Yes.
that way. So if you can start using reproduction, then you can combine these gametes from different species and get a much greater range of genetic combinations. And also seed, instead of planting like corn plants, you can plant seeds in fields so that you get a much better result. But I really love restoration because it's an underwater platform to test a lot of these different techniques. And just by doing what you've done, you probably learned a ton about what corals like and what they don't like.
Definitely.
And I think that's what we're learning. We've never tried to do this. And now there's a lot of people trying to do it, and we're learning like crazy. And what I like is that almost everybody I know that's doing restoration is very cooperative, and they're teaching each other because instead of like, patenting my little style of doing it, people are exchanging a lot of information to make it better. So I stay tuned and don't give up.
Yeah, thank you. I have to say the most hopeful part was seeing the corals in the nursery spawn successfully and have these gametes intermingle with between the most successful strains. So that was cool.
That is a great question. So this is what I'll say. When I was coming out of my undergraduate and went on to graduate school, I was fascinated by the symbiosis between the plants and the animals. How could you have a plant living inside of an animal cell? I mean, that's crazy right there. So that was what really, I was just fascinated. And the context for the work that we were doing at that time was so different. I mean, I graduated in the mid-'80s. I couldn't have imagined that we would be where we are today with climate change. It's just unfathomable to me that we are here at a point where we've killed 50% of the reef in the world. So I think that what I would say is, if I now were coming out of my undergraduate, I clearly see that what we have to change is human behavior. We have to somehow get people to act. We have to make people realize that they can't wait for somebody else to solve the problem. Everybody is the one who will solve it. And it has to start now for everybody. We all have to make choices that are about our future. So I think now I would probably be more drawn towards communication and social science. So, but to be honest with you, it's really, it's hard to make a really true answer to that because so much has changed. And I think we're in a position to do the types of things that we are trying to advance now because of this extraordinary basic science that's been done that allows us to feed it into a set of products that will solve the problem. So it really highlights just how extraordinary basic science is and the high value. I'm a reluctant academic myself, and I was reluctant because I find the sort of academic structure and hierarchy and tenure process bizarre. I don't think that individuals do science. I'm a team player. But as an environment, there are very few places where you can work, where you can be truly free and creative with your thinking and your actions and follow your passion. And so it's a fascinating sort of dilemma at this time. I think for anybody coming out, it is really that, what do I want to contribute and what really gets me up in the morning?
Thank you very much.
Julia.
Yeah.
I think if there's one thing we see from this movie, it's the power of the arts to influence your thinking. I mean, a picture's worth 1,000 words, and a movie like this is worth 1,000 scientific papers in terms of trying to get to people. And so when we think about what we can do, any of us, to help this problem, it is really about what your passion is. But whether you're a creative person or more of a technical person, or you combine those things in really, really amazing ways like we've seen here, I think it makes a huge difference.
So if you're not a successful filmmaker, like most people in this room, including me, what would you suggest is a good way of helping communicate these issues specifically from your nonprofits that you work on? Yeah.
So I've become passionate about communication as I have seen the disconnect between what we do as a society and what we know as science. I've also become passionate about it as I've worked on coral reefs all over the world since the 1980s and seen the decline in many different places. And so those are the kinds of things that motivate me to want to try to communicate better. I feel like in terms of how we go about learning how to do that, do things like this, right? You just keep doing it. One of the best things that I ever did, I did with Joanie, which was a training that taught us how to communicate better, and actually filmed us doing things like this. And then we had to watch the movie, which was really excruciating, but you learn a lot doing that. So it's been a passion of mine to try to convey some of that as well and encourage the students that I work with to become involved in those kinds of activities so that we can get the word out. It's really important whether you're a filmmaker or whether you're a scientist who needs to learn to speak in non-jargony terms to talk about science, or whether you're a teacher or a writer or even someone in your daily life who just likes to talk about climate. One of the things that we really don't do is we don't talk about climate change. Even if we think it's an important issue, it's become too depressing to talk about. It's become something that is too doom and gloom, and there's no positive story. And I think what this movie does and what we're trying to do in some of the work that we're starting to collaborate on here in Tucson is to think about solutions and ways to move forward in a positive direction. So trying to find those positive stories, and then don't be quiet about it, but talk about it. So.
That's very true. So, Prof. Gates, I liked what you had to say. I'm a wildlife biologist from South Africa, and I've worked on the coast and in the inland side. And it was only when I came to the States and studied here and I went back to South Africa, I thought, I'm not going to study the sex life of the lower spotted lizard anymore. I'm now going to get into environmental law, because we create all of this kind of stuff, but it's all comes down to politics. And it's all those, you have to change the politicians. You've got to get into their minds. And they don't want to hug bunnies and kiss fishes. They want you to talk to them in economic terms. So if you say it's going to cost you this much for health problems are going to be caused by this, this, and this, they'll listen to you then. But what does worry me is that we have 7.5 billion people on the planet at the moment. And if we last another century, we'll have another 11.2 billion people on the planet, another 11.2 million, of which most are coming from Asia and Africa. So then the planet becomes less diverse because we're heading for the sixth extinction, because things are just dying out. So do we vasectomize and tie tubes and cork all the cattle in the world so that we can stop the methane? I mean, it's just... This goes on, but it's not incorporated into the science of climate change, because that's actually the reality, is that we're going to go on producing more and more people, chewing up more places, and it all comes down to politics. And science is good, but they don't want to listen to it. I mean, if we have Mr. Trump in for another how many years, he doesn't care.
So I think you've hit on several things, and yes, we have a population problem, but I also think that it behoves us to really think about ourselves as part of the biodiversity rather than independent of it. And we think that the population will continue growing and that we will be immune from diseases that are linked to increasingly warm temperatures on the planet, and of course the reduction in the amount of drinking water, essentially the potable water. And so I actually believe that there are going to be some rather radical adjustments to human population that will relate to massive disease outbreaks that we can no longer control. And we're seeing problems already emerge that are starting to affect the reproductive rates of some populations. And so I don't think we can sort of speak about sort of the death of the ecosystems independently of the detrimental impacts of climate change on our own health systems and the availability of critical resources, because we are destroying our habitat, and that is a no-no from an evolutionary perspective. There will be huge consequences to almost every living system that supports us as we move forward. And that's already starting to show. So I think in terms of sort of the political climates, the governance issues, and how you interact your science through those, and how you sort of push levers to get things to happen quickly, it is a massive challenge. And the sort of, I'm a bit anti the idea that what we have to do is always put value on nature. But if it helps you sell the argument that gets the change in the governance structure to make it happen, I'm all for it. So I'm of the opinion that we just have to use all of our means to move needles in directions that allow us to both raise the awareness that humans are not immune from climate change, and also the governance and compliance issues that prevent us from transitioning science into action rapidly.
I heard a wonderful saying that said biodiversity or islands in seas of poverty are not sustainable.
That's right.
And that's the problem, is that there's so much poverty.
Well, and you know, whether
approaches because people are hungry. And
sure.
as that disappears, it's just not sustainable.
Well, I mean, we often talk about coral reefs and the really isolated Pacific Islands, where there are estimates of 70% of the protein comes directly from the reef. So the death of the reef in a place like that is really not only the death of the people from that place if they choose not to move, but it's also the erosion of the land on which they live. And so what we're looking at is massive ecological refugee movement. That is a catastrophic thing, because let's face it, we are not good at accepting people from other places into the environment to really compete for our resources.
Gloria, do you want to add anything to this conversation? I bet you do.
Sure. I think I don't necessarily have a fully formed thesis about this, but I think it's a very dangerous proposition to begin talking about climate change and other environmental issues in terms of we can't have kids anymore, we can't have cars anymore, we have to give up our air conditioning. You know, like I think people don't listen to that. We were just talking about communication, and people don't want to hear about the things that they have to give up in order to save the planet or save the whales or save the corals or whatever that your goal may be. And I think stepping back from the sort of philosophical problem, I think it's just an ineffective strategy to achieve the goal that we want. So like Ruth was saying, we can try to do many, many different things to move the needle, whether it's speaking in economic terms or speaking in value terms. So different populations will respond in different ways to different, I guess, types of persuasion. But I guess my uneasiness around, do we tie everybody's tubes, like, is that I realize that it's not a very useful, it's deeply depressing for one thing, but it's also just a way to ensure that nobody listens to you. And then you start getting into really thorny problems about, okay, whose tubes get tied? Who makes that decision? It's all very well for us to sit here in the richest nation in the world with, the vast amount of scientific knowledge that we have and, try to say that this is the optimal way for our species to shepherd our planet through the next few centuries. But the way these things usually work is that there are winners and losers, and the losers are usually the poor people who do not have a voice in the process. So there are a lot of things about that conversation that make me uneasy, and I'm not sure that I have a great answer to them. But
we have a great program here at the University of Arizona. Actually, it's a Tucson program. It's the Haury Trust, a woman named Haury, who was a great believer in social justice and also in the environment. And more, it's pretty clear that there's an enormous amount of social injustice created by global climate change that goes from, losing the water and where you used to plant to whatnot, or losing your corals where you got all your protein from. So I think it's going to become more of an issue as we move along, this business of social justice because of environmental climate issues. But, one of the things that all of you, I'm sure, are thinking is that these superstars are here because we have the film. But as you may imagine, we never planned these things properly. And it happens to be that these folks are here because we're trying to figure out if the biosphere is a place where a lot of the things that have been discussed can actually be actuated on as a laboratory for genetic issues and whatnot. So maybe, Julia, you want to say something about what was going on today?
Sure, I'd be delighted to. The biosphere has an ocean, and it's the largest ocean that is available within four walls, confined, for research purposes. So it's a very large tank that we can use to address some of the pressing questions in the world. And we think that one of the most pressing oceanographic questions you can address is the collapse of this iconic ecosystem of coral reefs. And so for a number of months, we've been trying to pull together some ideas about how we might use the ocean to address this crisis in coral reefs. And we had a workshop at Biosphere the last couple of days, bringing Joanie and Ruth and others who are here in the audience, Virginia and others, to come, and Katie and Franklin were there, to come and brainstorm with us about how we can use the ocean best. And I think the theme we came up with was the biosphere is a place to do the things we're scared to do in nature. Right? So if we want to breed modified corals and put them on a reef, well, no reef manager in the right mind is going to let you do that in the natural world because they're too worried about the fate of their own reef in its natural state. But we can do that here. We can put anything we want, mix species together that would never be found in nature. We're not worried about frankencorals. In fact, we were joking that if we had a frankencoral that took over the ocean, some of us might think that was actually pretty exciting results. So. So we're pulling together people that can take advantage of the biosphere and use it for the things that only the biosphere can do. We can build a whole reef. We can make a reef that has a full community structure, different trophic levels. We can study the heck out of it and monitor the heck out of it from the genomic level up to the individual level, to the behavioral and community ecology level, and even to globally significant things like greenhouse gas fluxes. So we can do an awful lot with coral reefs within these four walls of the biosphere that will help us understand how to deal with the modern reef crisis in the real ocean better. And we're going to be very solutions focused on this. So we're going to try to look for things that can be quickly translated into the real world to help people who are actively doing reef restoration in all around the world to use the kinds of results that we have. For example, can we make a Lego reef, a reef that you assemble and tie some corals to that you could actually put in a place where a reef had been destroyed by a disaster, but that Lego reef might grow the corals that will allow the fish to come in and continue to provide food for people who depend on it. So we're not creating reefs, and that's far-fetched. I realize that's one of the crazier ideas we had. So don't go quoting that in the newspaper or anything. But we had some ideas that, what can we do in here that how can we think outside the box to help preserve corals and reefs, but also for the people who depend on them, help preserve the services that those reefs provide, whether it's food or whether it's coastal protection. What can we do that will do something so that we're not doing nothing? Because if we do nothing, we have nothing left in 50 years, right? Or even in 20 years. We have no corals left if we don't do something. So we have to do something, and we're trying to use the biosphere as a place to think outside the box to develop solutions.
I just want to add one thing because I think it ties in with the question that I wanted to thank you for first taking the legal side of things, because I think there are not many of us that are brave enough to do that. But this sort of ties in. What I like about the B2 discussions is that we, if we're going to change the planet and how we manage these ecosystems, first we have to educate people. And that's why this film is so good. It reaches many, many people. And I know for a fact that some of these congressmen that were staunchly anti-climate have now flipped after seeing this movie. So that's a huge success already, right? So I think that's a good thing. But like this Biosphere 2 issue, what it does is it is a way to give us hope that we have a path forward for a solution to buy us time until we get our act together on the climate change issue. And so I think this is just a great example of saying, okay, here are the solutions that we're testing in the Biosphere 2 that we can move out rapidly after they're proven into the real world and get these things propagating faster than we ever thought possible. So I think that sort of, you know, the Biosphere 2 is, we would not be able to test these things without a facility like that that will get us in the field quickly with solutions.
I'll add one more. Really, people criticize the approach of trying to do something. People are worried about the risks of, you know, directing the genetics. And people say you can plant a garden of corals, but you can't build a reef. Well, what I say, and I think what we're all saying is, bring it on, people. We are going to take these criticisms to heart. And instead of responding by saying, oh, let's just walk away, we're going to try. And we're going to try and look at those issues and address them. The reality is we'll be successful at some things and we'll fail at others. And one of the things that we've all shared a lot this week is this desire to be completely transparent about the scientific process. Let's face it, for all the scientists in the room, we fail all the time. And we never tell anybody about it. For us, our goal is to tell people, we failed at this, don't try it, move on to this works better. We have no time to mess around. We have about 15 years to be intervening physically on reefs. We have got to do things differently. We're asking the world to change the way they do business. So we've decided we're going to demonstrate a change in the way that we do business as scientists. And everybody in this room can make decisions like that and choices that will affect the future. Thank you.
You get the last word.
Yeah.
Oh gosh. Well, I was just going to say, you know, if I leave my garden alone that I've planted and put in nice rows, like some of it's going to die, but it gets pretty overgrown pretty fast. It becomes a forest kind of in rapid time, even in Tucson. So I say build the garden.
Yes, and stay optimistic. That's the key.
We are done.
That was great. Well done. Oh, nice work.
Take care. Have a great rest. Very good.
Hi, I'm